All right, welcome back, scholars. It's me, Mr. Who, back with the final quarter of the year. And we're going to move on, continuing on from our idea with law of sines. We are going to talk today about the law of cosines, okay? Law of cosines. So, with the law of sines, we kind of looked at it, but recall that the law of sines works with any triangle. Okay. And with law of cosines, the same applies. You can use these law with any triangle you see. Okay, no matter what side, what angle, what have you. You can use law of cosines on any triangle at all. So, where law of sines was more of like a ratio of sine A to side A, sine B to side B, okay, all that other good stuff. This is a little less like that. This is more like Pythagorean theorem in the sense that I'm going to provide you with a couple of formulas. They're all basically the same, but with some parts moved around. And the reason it looks like that is because it is actually based on the Pythagorean theorem. So I'm going to go ahead and write the first version. Okay. C squared equals a squared plus b squared. There's the classic Pythagorean theorem. Okay. And then here's the new part, which I'm going to use a different color for it. Okay. The new part is minus 2ab cosine c. Okay. Minus 2ab cosine c. So go ahead and write that down. That's the first formula in law of cosines. But as you might know, in a triangle there are three sides, so there is also another formula for each of the other side combinations. So I'm going to go ahead and jot those down here. Feel free to also write them down, but as long as you know one, okay, of the formulas, you are probably fine, because I'm going to tell you a neat little trick that will help you identify where you need to plug things in when it is necessary. Okay. So here's the second one. All you've seen I've done is replaced C with A, and so all of those things kind of moved around a little bit. You can even move these around if you want to have C where A used to be and B is over here. It doesn't really matter. Everything here is commutative. Okay. And the last one is where B is the focus. B squared equals A squared plus C squared. And then we have that minus 2AC cosine of B. Okay, so those are the three formulas. Again, try not to memorize all of them. Okay, you don't need to really, but as long as you know one of them, or you know how one of them works, particularly this one right here, that I'm going to box in pink. Okay, that one is the one that looks the most like Pythagorean theorem anyway. You'll probably be set for this. Okay, so let's talk a little bit about this formula. Okay, it is pretty apparent that, let me go ahead and select the color here. It is pretty apparent that this, that this first part is Pythagorean theorem. Okay, I don't think anyone will argue with me. I think everybody knows this is Pythagorean theorem. Everyone loves it. Everyone knows it. Okay, maybe you don't actually love it, but very useful. You've talked about it forever. You should know this. It's probably like the back of your hand right now. So the part that's actually new, the part that is new here is this part over here, the minus 2ab cosine c. You might be wondering, how does this come about? Why do we need this? Well, we only need this, okay, to qualify any triangle. So let me draw you a couple of triangles that are just, any triangle and not right. So there's one side. Here's two side. Three side. Okay. Now, when you're looking at this, it's hard to tell whether it's right or not. Okay. Which, yeah, it's probably not right. Okay. It doesn't have to be. And it's got three sides, A, B, and C, where you've got angle A opposite of the side A, angle B opposite of side B, and angle C opposite of side C. This is all the same from law of sines, so hopefully this is just a bit of review for you. Now, in a non-right triangle, okay, we know Pythagorean theorem doesn't hold, but through some geometry, some other trig, using actual right triangles, okay, using something like this, okay, for example, where you cut it now, and to your point, there is now a right triangle inside my normal triangle, and a bunch of other stuff, which I'm not going to show. Okay, you can come up with this extra little tag along that qualifies for every triangle. All right. So in other words, the law of cosines is kind of like a Pythagorean theorem for any triangle, and not just the right ones. So let's take a look at the finer details to help you kind of get this down more, to understand it a little more, and then we'll go to practice. You can watch the practice after this. First of all, c squared on the left, that is our target. That's the target side. Maybe you do know it, but chances are if you're trying to look for it, you don't know it. Okay, that would be this guy right here. This is our subject matter. And you'll see that in the minus 2ab cosine c part, the c lines up with the target's opposite angle. Okay, so on the left side, I have c the side. On the right side, in cosine, I have c the angle. That's one easy way to figure out where to put your numbers. Okay, so it'll probably do you well to label all your sides and angles, and what you know, what you don't know, and go through like this. Right? That's, of course, if I'm looking at it from the C angle. If I'm looking at it from the A version, then, well, you're going to be looking at A as the argument, which means it's this guy. And over here, what do I see? Big A. So here's our target angle that we need to put in our cosine. Okay. And you can apply the same to B too. Now, that's all good and fine. You probably are wondering how we're going to use this on Delta Math, okay, or how we're going to use this when we move on into calculus and all that other good stuff. So let's head over to the practice and take a look at those.